Hello, children. How are you all? Hope you are fine and you might have spent your holidays happily. Okay, for this academic year, from your science book, let us start a topic force. You are all well aware of what force is. You have studied in your previous classes. Just let us give a look into it and then recollect what are the things that are involved while we discuss about force. Here, you might have seen so many examples from your childhood that by applying a force only, you would be able to do few things. At that age, we don't know that what the thing that we are applying is called force, but now we know it. As such, you are breathing in, suppose. Guess what happens? The muscles of the lung expand. When you breathe out, again you can see that they compress. So here what is happening? There is a force acting here. Now you can see the borewell people drilling the pipes into the ground. So what is happening there? You can observe that the pipes are pushed into the ground. They are pushed into the ground. So when anybody knocks at your door, you'll go and open the door. So you'll be pulling the doors inside. When you want to close the doors, you'll be pushing them. So when you are going to the school, you'll pick up your bag, lift it up and then put it on your shoulder. And when you are writing, you will hold the pen and see that it should not slip from your fingers. Everywhere, in all these things, even when you want to drink a tumbler of water, you need to hold it. For holding that also, there is force acting. Even when you need to walk, there are forces acting. When I am standing here, there is a force which is letting me stand. So everything in this world, for everything to be in its appropriate place and for every action to work properly, there is one or the other kind of the force acting in every instant. You'll be surprised to say that there is not even a small event which can take place in this nature without action of force. Interesting, is it not? So therefore, now let us proceed to the topic of the day, force. Now how to define force? Now combine all these things. So when you want to fold a napkin, you need to apply some force. So when you want to pull open the rubber band, you need some force. So here you can see that there is an increase in the size. And when you just crush a paper, you can see that there is a decrease in the size. If you keep an object on a table and then you push it away from you, it is moving. And if you want something, usually which is far from you, you will try to pull it towards you. And even there is a motion. If you want to stop a moving ball, you will apply force. So, what is force doing here? Force is doing many things. Let us see what they are. First one, it may change the shape of the body. It may change size of the body. It may change the motion of the body. It may change the state of rest of the body. So what a force does? Force does so many things, right? So now let us define force like this. Force, when it is acting on a body, may bring change in the shape or size or state of rest or state of motion. I repeat this again. Force, when applied on a body, may bring change in size or shape or state of rest or state of motion. So force does this much. So children, try to write the definition. I'll repeat it. Force, when applied on a body, may bring change in shape of the body or size of the body or state of rest of the body or state of motion of the body. Here you can also write it in your own words. It is not necessary that you have to put in the same order. But you need to remember that what are all the things that force can bring in. Okay? So now each category of the example, whatever we have taken here, comes under different types of forces. Let us confine ourselves to two types of forces right now. Here they are. One is contact force. The other type is non-contact force. So from the name itself you can say contact means when the force is in touch or when the force is going and touching the body. That means the source of application of the force must be in contact with the body. Suppose I wanted to erase this line. So my hand should be in contact with the board, surface of the board. Thus, whenever a force is acting on a body in such a way that there is a contact between the source of application of force and the body on which the force is applied, we call that force to be contact force. So, a force which acts on a body only when the source is in contact with the body is called a contact force. I repeat this. A force, when acting on a body, is in contact with the body on which it is acting, then the force is called contact force. Now coming to non-contact force. Yeah, it is very clear from the name, right? It is not necessary that the source of the force is in contact with the body on which it is acting. Can you guess an example for it? Yes, it's magnetic force. So when you keep a magnet nearer to a small iron piece, you can see that the piece jumps and then holds, or then it is pulled towards the magnet. Here the magnet need not be in touch with the iron piece. What happens here? The magnet pulls the iron pieces towards it without being in touch with the iron pieces. Any other kind of force if you can guess? Yes, gravitational force. Right? Whenever you drop an object, it obviously falls down. Why? It is the earth's pulling force. Even though it is not contact with the body which is falling on it, it pulls it towards it. Yes? So that is what, there is a famous story, Newton's apple. Yes? So it is Newton who is able to say that there is a gravitational pull to earth. Okay, so these are non-contact forces. So then how to define non-contact force? Some of you might be already ready with the definition. Yes. So now here let us put it, the whole thing, in the form of a definition. A force which is acting on a body from a distance is called a non-contact force. So it is acting from a distance. It is not necessary that it is in touch with the body on which it is acting. So therefore, non-contact forces can also be said as forces at distance. Forces at distance. So again I will repeat the non-contact force definition. A force which is acting on a body from a distance, not being in contact, is called non-contact force. Very simply, a force which is acting on a body at a distance or from a distance is called non-contact force. Is that clear, children? I think you can write on your own the contact force definition and the non-contact force definition. Contact force is a force which acts on a body where the source of force is in contact or touch with the body. Non-contact force is a force which acts on a body from distance. So, now, what are the things which come under contact forces? What are the kind of forces which come under non-contact forces? Now, can you all see here? So, the first one is the muscular force. Muscular force. See, when you are talking, you can see that the muscles are moving. Even to talk, we need some force to be applied. We have also seen the example of breathing in and breathing out where lungs contract and expand. If you want to close the eyelids and open, even there is a force acting. And all these bodily forces which come into action for doing any physical activity, those are muscular forces. Like suppose if you are trying to lift something, you can see that the muscles of your shoulder will be lifting along with it. That means it is something like that. There is a force acting here as well as at the elbow. And the second one is frictional force. Yes. Suppose when you roll a body on a smooth floor, what happens? Depending on what force you have rolled it, it will be moving a distance and stops. So what is that which is stopping this rolling ball? You can't see anybody there who is stopping it. but it stops. After going some distance, it stops. You know the reason? The reason is here the friction between the surface of the ball and surface of the floor makes the ball stop. Makes the ball stop. Suppose you are stepping on a very greasy surface. What happens? You will slip. Why do you slip? Because you are applying a force in this direction as you are putting your leg. So this force is not opposed by the friction. Usually if the surface is not greasy, then the surface on which you are stepping and the surface of your foot both together experience a relative resistance. What do you mean by resistance? Here opposing. So you are applying a force. Now this is trying to stop it. So therefore you won't skid. So but what happens here? That grease or the oil which is there between these two surfaces is reducing that friction. So it's very clear that friction, even though it is a resistive force, it is a force which opposes the movement, but it is very essential, is it not? Very, very essential. Okay, so now what is friction? Friction is that force which opposes the motion of a body on the surface of another. So if this is one body, if you take, and I am trying to just move it on the surface of another hand here, now the friction is opposing the movement. So friction is a resistive force, or simply you can say in your own words as that which opposes the movement of a body on the surface of another body. Right? This is a frictional force. Here also you can see that both are in contact. Even in muscular force you can see that while lifting the body you have to hold the body and the lift. While pushing you have to touch the surface and push. While pulling you have to again hold the body and pull it towards you. So here also the source of force is in touch with the body. Here also the source of the force is in touch with the body, and this one is normal force. Normal force. How do you understand this normal force? See, I am standing here. Do you know that I am applying a force on the floor where I am standing? Yes. As well as you people are sitting and listening. Now where you are sitting, you are applying force on the surface on which you are sitting. So you are applying a force. See, I am applying a force here. So it is supposed to push it like this, right? But that is not happening here. Why? See, when I am standing here, I am pushing the floor. But the same amount of the floor is applying perpendicularly to the surface. Right? This is the surface. Absolutely perpendicular, means at 90 degrees of angle to the surface. There is a force in upward direction. See, when I keep an object on my hand, now let me pick up a pen. I am keeping this on my hand. And when this is applying a force on my hand, then again there is a force acting perpendicularly on the pen in upward direction. Okay, that is called normal force. It is called normal force. Normal in the sense perpendicularly. Perpendicularly means with the surface the direction of the force is always makes 90 degrees, or is always acting at 90 degrees. That is called normal force. Anything, when you are putting an object anywhere, whatever the force that the object is applying on the surface also immediately applies the same amount of the force opposite to it, as well as perpendicular to the surface on which you are applying the force. Perpendicular to the surface on which you are applying the force. So that is called normal force. That is called normal force. So let me explain it here like this. See, I have a table. And on the table, I am putting an object. I am keeping an object here. Okay. So this object, whatever the gravitational pull that the object is experiencing, this is absolutely downwards like this. Because earth is pulling it towards it, right? So you have the surface of earth here. So it is trying to pull the object downwards. And that is what the force which is acting on the surface of the table. Now the table is not breaking and then letting the object come down. What is happening? This table, the surface of the table is also applying a force perpendicular to the surface, 90 degrees. Right? And this force which is acting upwards, right? And this is applied by surface of the table. This is applied by the surface of the table. How is that applied? That is applied normal to the surface. That is perpendicular to the surface. That force is called normal force. Is that clear? Yes. I'll define it like, see, when a force is applied on a surface, then the force of reaction which acts perpendicular to the surface and opposite to the active force, that we call it as normal force. See here, normal force by itself it won't act. Right, see, the board is here. Now I am trying to push the board like this. So as I am applying the force here, I can experience a reaction from here. Even this is pushing me away from it. As I am trying to push it inside, it is trying to push me away from it. So that means the force which is acting is outward. This force is acting outward, where my force is acting inward. And this is outward. But how? See, this is the surface. This is the surface. With the surface, it is making 90 degrees of angle. 90 degrees of angle. Perpendicular. Absolutely perpendicular. So such force is called normal force. And usually this is a reaction force. This is a reaction force. That means whenever you apply some force, there will be a reaction from the other side, and this is the reaction force. Clear? So therefore, normal force is a force of reaction which acts perpendicular to the surface of the body. Okay, right. So then next one is tension. Next one is tension. So what is tension? I will give you an activity here. After the class, take a bag or a basket and put one kind of the vegetables into it and try to hold it. After that, add some more of another kind. Then observe what is happening in the muscles of your hand. And again put some more. You can feel that something is pulling your hand down. The more you are adding into the basket, the more pulling force you will be experiencing. So how you are experiencing a pull downwards? In a similar manner, the bag is also experiencing a pull in upward direction. In upward direction. That is called the tension. That is called tension. I'll explain you here. Suppose there is a branch, a tree branch, on which you have a swing. If a child sits in this swing, you can see that there will be a stretch in the string here. Yes, you can observe. If you carefully observe, you can see that there is a stretch in this. And that is the tension. And that is the tension that is acting in the string. In which direction? That will be in the direction where it is fixed. Where it is fixed. So tension is again a contact force. Only when you go and touch it and then you try to pull it down, then you can see that there is a tension created in it. Okay, so therefore this is also in contact. Here normal force, it's a reaction. Only when you apply some force physically in touch with it, then only it again comes into action. Frictional force, absolutely, only when both the bodies are in contact, as well as one should move with respect to the other. If they are like this, there is no friction acting. Children, please remember, in the next coming classes, you will understand that when both the bodies are in contact, just like that at rest, there will not be friction. But when one is moving in relation to the other, right, keeping one at rest and trying to move the other on the surface of the first, then only friction starts acting. So definitely frictional force is again a contact force. Muscular force is again a contact force. So muscular force, frictional force, normal force, tension, all these come under contact forces. All these come under contact forces. So simply just understanding it, very quick review of the things. Muscular force, that means whenever you wanted to use some force, so the force that is applied by the muscles of your body, muscular force. Frictional force, whenever a body moves on the surface of another, frictional force comes into action. Normal force, when the force is applied on the surface, then a normal reaction, that means a reaction will be there which is perpendicular to the surface. This is the normal force. And tension, just whenever it is a tension, think of a string, a load which is hanging at one end of the string. Then there is a tension. So there is a tension in the string. The force that is acting inside the string. That is the tension in the string. Is that clear, children? So in the next class, we are going to see the details of non-contact forces. So for today, let us start with the contact forces. So you can give an example of each one. Muscular force, frictional force, normal force and tension. Everything can be done as an activity at your home. So stack 4 or 5 books at a place and try to lift them. You can observe what kind of muscular force is acting, and then please make a note of it, what you have experienced. That will be an activity. And then frictional force. So you can make a ball roll on a smooth surface. Take an observation of it. And then now just put your napkin, hand napkin, and then roll the ball on it. You will observe a difference and then note down that difference and try to compare both. This makes another activity. Normal force. You can just keep a book, right? See, on a very lighter surface, suppose you take a shoe box. On the shoe box, just keep some weight. You can see that there won't be any change in the shape of the box. If you increase the weight, at some point, then you can see that the box collapses. Till then, there is a reaction force. Till that point, there is a reaction force, and that is getting balanced. The action and reaction. Okay, and then now fourth one, tension. I already said, take a basket and put different kinds of vegetables step by step. You can see the increase in the tension. Increase in the tension in your hand. Here the string is your own hand. Okay, children? Yeah, please try to do these activities, observe and understand. The basic principle of science is not learning and by hearting, but understanding the phenomena. That is very, very important. When you understand the phenomena and when you experience it, when you observe it, then you will start loving science. So the secret towards interest in science is you need to understand, observe and experience it. So please try to do these activities and then experience how the force is acting, where it is acting, from where and what are the effects of this force. Okay? And this is all for today's class. See you again.